welcome back to SNT Networks. In today's video, we'll be taking on the sixth part of the series, Network Engineer Interview Question and Answers, and this one is going to be of level hard. So before coming to this video, I would suggest clear of all the topics, the previous topics, basic terminologies, and then only come to this particular episode because we have a few things here like load balancers, IPsec, SSL, SASE. Here you might get a bit confused, and I strictly recommend this is level hard. Okay, so starting with the first question, how does a load balancer maintain session persistence when SSL offloading is enabled, and what are the risks involved? So first of all, you need to know what a load balancer is. That if you have servers in the backend, that makes sure that the load is balanced according to different criterias and different ways like round robin, wait, write persistence, all of that. That is the basic. Now you're saying that how does a load balancer maintain session persistence? So persistence is making sure. So for example, this is your load balancer. These are your servers. Okay. And this is your client, for example. Okay. Now the load balancer main job is to make sure that none of the servers are overwhelmed, the basic task, and also to make sure that load is distributed according to the needs, you can say that, and making sure that none of the servers are overwhelmed. So first of all, how does a balancer maintain session persistence? Persistence again is a way by which you can say, sort of like if you know about basic load balancing in ECMP, you can say that it can maintain sticky sessions. Just like you can make sure that if this a client tried to make a connection with the server and first time it went to the server and you have persistence enabled, then persistent cookies or they have different criteria for persistence. Persistent cookies are there. You have IP based persistence. Accordingly, for next time when you try to maintain a connection, it will not take you to this server. It will take you to the same server just to make sure, and it also helps you a lot with the latency part as well. Okay, and even the server does not get overwhelmed. Okay, so this is what persistence is, and you have SSL offloading. When SSL offloading is enabled, what are the risks involved? So now you need to understand what is SSL offloading. So, so what happens is, for example, you're trying to make a connection. Let's clear all this off. We'll create a very simple diagram for you guys to understand. So this is the client, this is your load balancer, this is your server. Okay, now when you try to make a connection with the server, right? By the way, there's a thing called SSL decryption. Okay, once you send the client hello, when the server hello comes back, because your default gateway will be the load balancer, it will stop the server hello, take out the keys, and then what happens is you make a connection. So the client will think that it has maintained a connection with the end server, but actually the load balancer sends you server hello and it removes the the keys and adds its own certificate and keys. So basically when you try to make a connection, the connection is between the client and the load balancer, and since the load balancer already has the server's hello and the keys, so what it does is it makes a connection. So it's like you were supposed to make a single connection, right? But the load balancer using decryption now. So what it does now is you have the certificate, that the same certificate will be loaded here, and the client will have the server certificate. Okay, now you have two separate connections. One connection is here, second connection is here. So every time you try to fetch some information from the server, so when the server responds back, okay, so this is again encrypted, this is also encrypted, but when the server responds back, here you will decrypt the packet, right? Encrypt with your own certificate and then send it across, because this is also encrypted using the load balancer certificate. Well, you understand, it's like breaking an encrypted tunnel into two encrypted tunnels. Okay, and right now we are using two keys. One key will be here from the which is made from basically client hello, server hello using sudo and function, but the pre-master key will be made by the load balancer, and it is encrypted using the what key? The server's key, public key. Here again, you have a different set of key. Okay, but this will be made using client random, server random, using sudo random function, but will be made or encrypted and sent via the load balancers key. Okay, these are two separate things. Now what? So offloading basically means that, you know, basically when rather than sending the traffic directly to the server, you're offloading traffic to a load balancer to make sure that not all the encryption and decryption happens here, but the load balancer takes care of that part. This reduces CPU and like a lot of load on the end server. So what they are trying to ask is, how does a load balancer maintain session persistence when SSL offloading is enabled? What are the risks involved? So sometimes, you might be confused. What is SSL offloading? Is this SSL decryption taking off? You're offloading the work from the server, end server, to the load balancer. Simple. So if you understand this, you can say that how does it maintain sessions? It uses persistence. How does it use persistence? It injects session cookies. It can use IP affinity. It can use session IDs. Okay. So whenever you make a connection, let me just rub all this off for you guys to clearly understand. I hope this part was clear. Now we are talking about very little about persistence. Okay, I think rest all everything is completed. So just about persistence, when you have a connection here and you have a connection here, the load balancer will insert a cookie. So every time you make a connection, you make connection with that cookie. You request it here, then the load balancer requests it, and then you get the response back. Correct? Now the way it inserts cookie can be among 3-4 ways. Like you can say that simple persistence cookies, right? There will be a cookie value when you check your HTTP header. You can say check the cookie. Then you can have session ID. You can have IP routes, IP affinity. By all these things, it inserts cookie so that whenever you make a request, you request with that same cookie, and then you're sent to the actual same server, which again in turn reduces the load. Okay, so this is how a load balancer will maintain sessions. It will also hold the cookie and it will match the session accordingly. It will send it. Okay, this was one question. I hope this was clear. So, like I told you, you would want in-depth technical knowledge to understand these because I will not be covering a lot of very basic parts, right? At least you will need to know the basic parts so that you can basically understand and grasp all of the key points that I'm trying to tell you. Moving on, what are the key features in how SSL inspection and IPsec inspection, IPS, sorry, works in a SASE environment versus traditional perimeter environment? Right. By the way, for the first part, we were supposed to discuss what are the risk involved. Risk involved, like I told you, will session will be decrypted, your packet will be decrypted, right? So there is a risk that decrypted traffic temporarily will be residing on the load balancer, right? And if the load balancer is compromised, your whole network can be compromised, right? So that is why you need to make sure you know your load balancer is safe, and you also need to make sure that the cookies are encrypted. If they are not encrypted, then it's again an issue. Moving on, what are the key second question, what are the key differences in how SSL inspection and IPS work in a SASE environment versus traditional perimeter based? So now in traditional cases, what happens was SSL and IPsec are located usually in the firewall or end, and you can say that perimeter basically. So this was your whole network. This is your whole network. You will put your firewall here and you will put your IPS here, something like this, right? And you make sure that first IPS is passed, or you will put your IPS here just to make sure your decrypted traffic comes here. You have SSL here, your decrypted traffic comes, IPS inspection is done, and then you let your traffic enter your devices and then access the servers, whatever, right? So this was traditional way of doing it. Now in SASE architecture, it happens as points, basically distributed points of presence near users, basically. Okay. And since it is very cloud native, in SASE, you know how it works, right? SASE is very cloud native, and you use ZTA. You mainly have zero trust, ZTNA, you can say that, zero trust network access, right? And then you have different micro segmentations across networks. Okay. And then among this also you have orchestration and like CAS, you have CASB, you have you know, you have CASB, you have Zero Trust, you have SD-WAN, right? Different. So we are talking about SASE altogether, SASE. So here in SSL inspection will basically happen at distributed points right, across near users basically. And since it's cloud native, it can scale dynamic with demand. Now here, what happens is SSL inspection will be integrated with user identity. Okay, device posture, geolocation. So like I told you about ZTNA, once you try to log in, it's always, you can say that, never trust and always verify. Right, if you are internal user or external user, right? ZTA holds that principle. So now here what will happen is you have to make sure that every user which is trying to connect, if it's internal or external, right? You have to make sure that they apply to all the AAA criteria: authentication, authorization, and accounting. Accounting is fine, we will not include that, but authentication, authorization, you have to make sure they comply to both. Plus, along with that, in authorization, you can say that we can use host checker, right? Device posture, you call it geolocation, right? Real-time, threat management. So here itself, you will have basically SSL inspection because you want to check the packets what you're trying to send inside belong there or not. By belonging, I mean you have to decrypt and scan them first, right? So SSL inspection will happen at the distributed points of presence. Okay, and IPS, you can say that since IPS and SASE are cloud delivered, IPS engine monitor traffic post decryption. So like I told you, it will again be the same, but once a user is trying to log in, right, it uses ZTNA in the lightweight agent. Here itself, SSL decryption will happen. Post that, you will use IPS because you need decrypted traffic to inspect IPS. Okay, and then you can use threat detection using ML or AI. Nowadays, we use both real time and real time inspection with ZTNA policy enforcement, or you can say that host checker will be used. Simple. It's very simple. Okay, now it's like the only difference would be traditionally use ISL inspection with mostly load balancer or the firewall. Now you use with GTA in the whole SASE behavior. Okay, I think this is also clear. Moving on to the third one. What happens when IPS is placed after load balancer that terminates SSL? How does it impact visibility and threat detection? Now you need to understand the simple question. So you have a load balancer which is terminating an SSL connection. This is a server, this is a load balancer. You're terminating an SSL connection here, right? And you have an IPS here, for example. Let's remove the client. Now what this is trying to say is how does it impact visibility and threat detection? Because the session has terminated there, correct? So uh, now this is your simple diagram. Now let's take a real-time scenario which will help you understand better, and then I think you will have a simple idea. Okay. Now we can say that if a user is here, okay, simple, user is here. Now, if all the SSL inspection ends here, okay, the session terminates here. Now, I don't think you will be able to see the decrypted traffic, correct? First of all, so only DPI is okay. We have two things here. Okay, let's take a simple scenario. Like I told you, we have two things here. Yeah. It can be either or. First of all, there's a load balancer. So you say that tunnel ends here. So you decrypt the traffic and then you send it internally. So once it is decrypted, IPS will be able to inspect the traffic properly against its signatures, against its AI and ML based threat detection, and tell you whether in even in real time this packet or this the packets or whatever excuse me, whatever you can say that payload that you're sending inside is safe or not, correct, using against it'll check against the signatures. Okay, now the issue is if it is plain text. Okay, if it is plain text, IPS will be able to check, but if it is not plain text and the load balancer re-encrypts traffic for the backend, like I told you initially, if it re-encrypts, right, the IPS will not be able to see the context unless it is again SSL aware. Even the IPS is supposed to be SSL aware. It needs to support high throughput. It needs to also do application layer decoding, right? And like as per security, I'll tell you, it should be it must be isolated in a trusted zone just to make sure, because most of the times it will not be SSL aware and the traffic that you send will be plain text. And if you understand plain text, then it is not secure at all. Okay, so this is what happens when you place IPS is placed after load balancer that terminates SSL, and how does it impact. It will help you. It will definitely help you, but you also need to make sure that IPS is placed in a trusted zone and it is also secure. Moving on, in a SASE plus zero trust architecture, how is user identity verified? So it is again very simple. No need to go in a lot of details. Simple. When you're a user, you're not at home. You're not at office. I'm sorry. You're at home. You use the lightweight client. You have a lightweight client. Use lightweight client to connect. It helps you with ZTNA. Either you use proxy or you use connect directly, and then this is your packet. Okay. By the way, using it once you're connected, right? Once you have authentication, authorization, and using your IEM structure, you're connected. Once you're connected, it will redirect you to the application you're trying to access, on which you have a CASB, right? And you have a secure web gateway. Nowadays we integrate both of them. Even Netscope has started integrating both of them. So this will apply security policies on it, right? Firewall rules, right? And then security posture that ZTNA will also apply. Once this is done, okay. Once this is done, you will get access to your server. So this is a typical SASE architecture. Okay, I'm not considering SD-WAN. This is very typical SASE architecture, right? Now, what is asking? How is user identity verified before allowing SSL tunnel creation to edge nodes? Okay, now this is how you usually connect to a simple, uh, you know, uh, SASE environment. That's it. So the authentication either be done by SAML, right, or you use OIDC or use OAuth. Okay, and but the major chunk will be the ZTNA, which will make sure that your posture aligned, your device belongs, even you as a user, your credential belongs, and only then it will give access. And once this is done, only then your user will be able to create a secure tunnel to the application, and then you have a secure access. Most of the times, things like Zscaler will have a proxy device in between, which will do encryption and decryption both, just like a what do you call load balancer in between. But some networks do not have that. You can create a direct tunnel, which will also help you reduce latency, and also the key point that they have is privacy. Even Zscaler will not have access to your data. Okay, so once it is done, only then you will be able to create a tunnel. These are very short-lived dynamic tunnels, unlike static VPNs. And once you're done with the application, the tunnel will be turned off clearly. Okay, and zero trust is again a very good topic. If you guys ZTNA, I'm sorry. If you guys need to basically need a quick recap, just go ahead and click on the I button. That will take you to a previous video that we have created on ZTNA and Zero Trust Access or Zero Trust Network Access, and you will be able to quickly refresh. And it has mostly the points to understand the topic thoroughly. Okay, now I think this is also clear. This is a very small question, right? The way it is put up is I wanted you to understand just to make sure that you're not, scared of the vocab. Just try to understand the question and then answer. That is why we're discussing the question first, and then only then we are answering. Okay, last one. What is the difference between using IPsec VPN and zero trust network access for remote access, and when should one be preferred over the other? So basically IPsec VPN and zero trust in remote access. See, IPsec VPN traditionally was used to maintain connection between two servers side to side and branch to office or side to side. And users connecting here would have access to different servers altogether. Okay. A will have access to B and users of B will have access to A. This is IPsec, side to side. Now, what they are asking is when should we prefer IPsec basically for remote access? Okay. Uh, Now, let's start with IPsec. You need to use IPsec when you need full access to the other side. Okay, total access. Okay, Some of the legacy applications will also not support micro-segmentation, right? And if you have very limited remote user base, then you can use IPsec because it will be static. It will always be static. When should you use ZTNA? We have already used ZTNA. It is again the same thing. Never trust, always verify. Okay, it will never trust, always verify, keep monitoring, continuous monitoring, micro-segmentation, just to make sure you belong there or not. It uses micro-segmentation just to make sure, you're into different networks. If when one network is compromised, the other will be away, right? You use deception in that. That is comes in cybersecurity. That is totally different. But you make sure these are in different networks. So one network cannot touch the other. Correct. And ZTNA is mostly used when you have bring your own device or you work remotely, both of them. And ZTNA again you'll use when you're implementing SASE or cloud native. So it's again SASE or cloud native. You use SASE or sorry, we use ZTNA whenever you have tried to access a lot of network applications. And by network applications, I mean your cloud-based applications. Okay, so these are the few topics that we discussed today. 5 questions. I know it can be a bit difficult to understand, but just try to clear the topics first, the basic topics first, and then come to this video, and you'll definitely find it very helpful because the kind of terminologies and the kind of questions that we have tried to put up are really good for all the interviews, and they'll definitely help you. And these will be usually helpful for guys with experience from 5 to 15 years. This will definitely be helpful in network security domain. And I hope this was helpful. If you want me to discuss any other questions, please do let me know and we shall do so. And if you have any comments also, please do let me know. Thank you. I hope this was helpful. Thank you. Have a good day. Bye bye.